Dear students, as we have finished with the first unit, that is about the human reproduction, and second one we spoke about the reproductive health, right? Some of the questions I'll just list them out and you have to remember them, right? Some of the questions I'll just give you, just orally, later I'll give you, anyway the book it is given, and some of the soft copies we will send you for the questions for the board, right? So under reproduction of humans, anyway test you are having now, the reproductive systems, both male and female, then mammary gland, then apart from that the complete menstrual cycle, placental structure. These are the diagrammatic things you have to remember. Then apart from that, sperm and the egg you have to remember. These are diagrams. Then coming to the explanation point, you have to write about the spermatogenesis, oogenesis, mainly those are the, with scheme you have to explain, and the number of sperms formed and the whole spermatogenesis, and maybe we have already discussed about it. The questions will be asked as differentiate between spermatogenesis and oogenesis. How many sperms are produced, how many eggs are produced for one spermatogonal mother cell or one oogonal mother cell. So these are one mark questions you can get it. So apart from that, you have to learn about how many eggs are formed. I told you one egg is formed per 28 days. Then, but coming to the sperm formation, at per ejaculation around 400 million sperms are formed, right? So this you remember, the number they will ask you, the numbers of egg, and with respect to sperm is too high because most of the sperms are getting eliminated from the vaginal area and they may be killed or they may get toxic effect by the vaginal secretions. Then about the complete reproduction of humans, then embryo development, cleavage, blastulation, and then gastrulation, primary germ layers, and then about the implantation and how exactly the placenta is formed, what is the function of placenta, how to describe placenta, and apart from that we have the structure of embryo, how it is getting nourishment from it. Okay, these drawings you know. These for the coming one unit. First unit, that's a human reproduction. Second is about the reproduction, reproductive health, right? That I am going to give you in the coming. We have the previous the video I have done about the one chapter of reproductive health. We talked about the human population, impact of human population, how to control human population by various family planning methods, then sexually transmitting diseases, and what are the new ways when the childless couple can, how the childless couple can get the child through medically assisted pregnancy. This is what we learned in the second unit, that is about the reproductive health. Okay, that's about the overall summary. Now we are going to talk about the reproduction in plants. This is the third unit. So under reproduction you have human reproduction, reproductive health, plant reproduction, and reproduction in organisms. This is 4 units. This is the third unit I am giving you. That is about the reproduction in plants. So coming to the plants, you must be knowing most of the plants you will be thinking that okay, like rose and all, you can cut the rose stem and grow it into a new plant, that you know it. So some of the plants normally undergo vegetative propagation. By cutting we can grow them. But the major advantage for the plant is to undergo sexual reproduction, because sexual reproduction can result in the new evolutionary characters, new varieties are formed. Therefore, we have to learn about the sexual reproduction in plants. This involves the male and female sex organ structure and the flower structure, and how the male and female sex organs develop, their development stages, and then fertilization, then the type of fruits. Okay, let's begin with the reproduction in flowering plants or flowering plants. So first let me give you the structure of a typical flower, because only when you understand this you will understand the details of the flower. Okay, only the sex organs can be understood if you understand the flower structure. Okay, so let me give you this as the stem. This is stem I am drawing, and this is the stalk of the flower. We call this a pedicel. And above the stalk of the flower you get slightly swollen portion, we call it as the receptacle or thalamus. Okay, then this will lead to the formation of first corolla of the flower called as calyx. Right? Calyx are green, or sepals are the units of it, and they are green in color, and they normally help in protecting the flower buds. Right? So one more thing, whenever I am talking about the flower, I will not discuss much about the know the parts of the flower which are not used in sexual reproduction. So this calyx helps in protecting the floral bud and also for photosynthesis. Then we will move on to the next one. This is the petal, right? This is the second whorl called as the corolla or the petal. Okay, this is a corolla. Units are called as petals. So you can make out looking at this that the petal is having so beautiful color and all. It helps in attracting the insects for pollination. Then central portion we have the first whorl of the sex organ is the male reproducing structure. We call this as the stamen or the anther, and the whole whorl is called androecium, right? And the central portion what I give you is the gynoecium. The gynoecium is a female reproducing structure, and this will have slightly elongated or swollen ovary, elongated style, and tip of it is called a stigma, which is lightly swollen or it will be designed. So this contains number of ovules. So observe the drawing. Okay, this is the typical flower. Observe. Okay, so what are the things you have to label? First one, this stalk of the flower we call it as the pedicel, and the swollen portion whatever you are observing here, it is called as a receptacle, or you can call it as the thalamus. Then the first whorl of the flower, it is called as calyx, and its units are called as sepals. Then second whorl is called corolla, and its each unit is called as a petal. Then comes the male sex organ. We call the organ and the complete whorl as androecium, and each unit is called as the stamen or the anther. This is the complete female reproductive structure called gynoecium, the female structure, and its units are called as carpels. This is a male sex organ, this is a female sex organ. So this much about the flower you should know before you enter into the floral description, right? So what are the things you have learned is the stalk, which helps the flower to just protrude out and expose for the pollination. Then receptacle will hold all the floral whorls. Whorls refer to the group of floral members of the whorls. The first whorl is calyx, which is actually the green colored part, and normally in the bud condition it covers the complete petals and other sex organs, it will protect it. Then comes the corolla, it is the attractive portion of the flower. Normally, in some it may not be attractive, but it helps mainly in attracting the insects for pollination. Then comes the male sex organ called the androecium, its units are called stamens, it is a male sex organ. Female structure is called gynoecium, its units are called carpels or pistils. Now in gynoecium we have different parts. The uppermost part is called as the stigma, elongated portion is called as the style, basal portion is called as the ovary, and within this what you get, these are the ovules. This is the detail of gynoecium. Details whatever you want to understand, you have to learn first overall gynoecium, and it has so many parts. Then what are the functions? Here the androecium. So let me draw separately anthers and other things I will explain you. So if you observe, this is the stamen. Stamen will be having elongated structure called the filament. This we call the filament. And filament at the tip will have some connective tissue to which the anther lobes are attached. This is the anther lobe. Anther lobe. Okay. This is the structure of single stamen. Each stamen may possess small such dissected portions through which the pollen grains may eject out during anther dehiscence. This is first structure. This is the stamen or an anther. Gynoecium already told you. Gynoecium has three parts. One is ovary, style and stigma. And ovary contains the ovules. Ovules contain the egg cell. Egg is a female gamete. Then style helps in exposing the stigma to the tip. It will protrude out. The stigma is the one which collects the pollen grains. So whenever the anthers release pollen grains like this, in air they will travel and they may deposit on the stigma. Then pollination takes place. Once pollination happens, this pollen grain form the tube and fertilize the egg. This is how fertilization happens in the plants, flowering plants. Okay. So now you are to draw this diagram. Understand how to draw it. First, it's a very simple one. First piece also you might have drawn it. Just 1 minute I'll give you. Afterwards, I'll start up with the structure of the stamen and structure of the ovule. Okay? Just go through this. Okay, let us now continue with the next one. That is about the structure of an anther. Because a stamen, normally I showed you here, one stamen consists of so many parts. You can see here filament, anther lobes and the connective. Connective is internal tissue. This is the connective. Okay, this connects both the anther lobe and filament. So most of the anthers containing the two anther lobes are called as dithecous anthers. So anthers are of different types. First one I told you, it is dithecous anther having two anther lobes, what I have drawn. In some there may be monothecous anthers. What is the monothecous anther? It has single anther lobe. Monothecous refers to the anther lobe is only one, like this. It is found in hibiscus. It's a monothecous anther. But majority of the plants contain dithecous anther. So I will give you the section of a dithecous anther when you observe under microscope. Okay. So this is the tiers of anther or stamen observed under microscope. Okay. So you keep drawing this diagram because this is a 5-mark question to you from this part. Okay. So first I am drawing two anther lobes. This is one, like this, two anther lobes I am drawing. And here these are possessing 4 pollen chambers. Okay. This is the, like this. Here is one pollen chamber, here is another pollen chamber, one more pollen chamber, one more pollen chamber. 4 pollen chambers. You just learn how to draw it. And layers, the outermost layer, whatever is present over here, this we call it as the epidermis. Normally it is thick walled, normally made up of cellulose. This is the epidermis, outermost layer of the dithecous or monothecous anther. Then comes endothelial layer, slightly elongated cells are there. So this endothelial layer I just draw with slightly elongated structure. You can see here these are the endothelial cells. Endothelial cells you should draw a little elongated and with the radial margins having some thickenings made up of pectin, cellulose and pectin. This is the endothelium, right? So you need to draw carefully all these areas because this will take long time. But when you get to the corners of this, these are not thickened, just they will be very large without thickenings. This is called as stomium. Okay, these are all the endothelial cells. They are slightly elongated, radial elongated cells they are, and they contain some thickenings in them. These are made up of cellulose and pectin. Sometimes pectose also they say it. This is the second layer. This is the endothelial layer. Then third layer, whatever I am drawing here, it is called as the middle layer. Hardly 2 to 3 layers are found. They are very thin. This is the middle layer. Around 2 to 3 layers I will draw here. Okay. Practice drawing these things because it's almost every, just go through the, again whenever I say this question appears, you better once you confirm by going through the previous examination papers. You can see like this, the drawings how to be, they are asked. This is all middle layers what I am drawing here. Around 2 to 3 layers of middle layers you are going to get it. Right? I have drawn around 3 layers of middle layer. Okay? Okay. Then the internal area, the last one which is entering into the microsporangia, you will find elongated cells. This is called as tapetum or tapetal layer. These are the large cells and they are nutritive in function, and this is the tapetal area. These are very bigger compared to others, and they are multinucleated. They don't have one only, one or two, and they contain something called the Ubish bodies. See, whatever I am saying, you just keep concentrating on the diagram also and listen to me also. They contain something called Ubish bodies. These Ubish bodies produce sporopollenin. Right? Within this, you find the male gametes. These are the pollen grains. So one diagram I drawn like that. All the 4 pollen sacs you are going to fill it. Right? So now let me label, and you can help me in labeling. First part, it is called as the epidermis. Okay. Then the next layer I have drawn. What is the second layer? That must be, this is the endothecial layer or endothecium. Then comes the middle layer. Then the highly nutritive area I told you, this is called tapetum. Tapetum provides the nutrition, and also they are multinucleated, they contain Ubish bodies, help in the production of sporopollenin. And within this, whatever you are getting, these are the microspores or pollen grains. Okay, this detail you have to show, and at least one you fill it up. And this I told you stomium. This don't contain any thick wall cells, because at this area it may break open. Right? So this is one of the microsporangia I have drawn. This is another microsporangia. And this is one anther lobe, this is another anther lobe. This is one anther lobe, this is another anther lobe. This is the anther lobe. Here you get the connective. The connective tissue I showed you, there will be a connective present here. This is connective. So this drawing is a 5-mark question. Draw and explain the parts of TS of anther by taking transfer section of it. So you are supposed to draw this and explain the details of this. Okay? Right. So now after this, I will give one more diagram next to this. First you have to draw that. Afterwards you can draw this. This is about the structure of a pollen grain. So I will separate this. Now I will give you the structure of a pollen grain or a microspore. Very important for examination point of view. One pollen grain, if you observe how you find that, there will be a thin layer inside. This is called as intine. Above this layer you will find highly designed sculptured structure, which sometimes is not sculptured, that is called germ pore. Otherwise everywhere it is designed like this. It is called as exine. Okay, this is called the exine. Okay, this exine is highly sculptured. This actually, whatever it is produced, sporopollenin is deposited in this. Actually, this sporopollenin is highly resistant material, and it will not get destroyed or decomposed easily. Therefore, till now, whatever you have got, the fossils are the pollen fossils only, because they can live for a longer duration without getting deactivated or without getting destroyed. So this outermost portion, what I have written is the exine part. The inner portion is called as the intine part. And there are here and there, I told you, there are some pores present. These are called as the germ pores. Okay. Then within this you get the male gametic nucleus containing paternal set of chromosomes that are formed during meiosis. This is the male nucleus. Okay, this is the typical pollen grain. But this pollen grain will not be released at this stage. This is having single nucleus, having haploid condition. During germination, I will explain you how it is when it is released. Okay, so draw both the diagrams, structure of pollen grain they may be asking you, or structure of TS of the anther. Okay, draw for a while and then you continue with the next one. Okay, we will start with the female structure. Okay. Okay, friends, we are now going to continue with the female structure. Already I told you the TS of the anther. Now we will talk about the female structure. So what I already gave you was the style, right? There is an elongated style present and there is a swollen ovary. Any shape, it may be round, it may be elongated ovary, and tip will be called as stigma, right? This is the structure. This is the structure of gynoecium. Okay. What are the parts then? The upper part we call it as stigma. The elongated portion is called as the style, and the circular or the swollen part is called the ovary. Within ovary you find number of ovules that are attached to the placenta. You can see here I am drawing. This is the carpel, or it is the carpel. These are the ovules. This is the ovule. This is the attachment to that. We call this as a placenta. Okay. So while writing gynoecium, they will be getting a lot of questions they have asked. Therefore, before understand the details of ovule, let us go to the ovary itself. So if you take the ovary transverse section, ovary in TS means this portion you cut and observe, what you will find. So the circular appearance, okay. Then there will be number of carpels produced from these carpels may be attached, they may not be attached, like this I am drawing. You can observe that they are separated like this. These are the various carpels. Then here there will be a placental tissue present at the center. This is the placenta. The placenta is a nourishing tissue for the growing embryos or the ovules. To this normally the ovules remain attached. You can see here 1 or 2 ovules I am showing you here. First, second, see so many ovules I am drawing here. Okay, this is the structure of ovary. So how do we label them now? This is called as the ovary wall of the ovary. This we call it as the locule, internal the area, chambers are called as the locules, and the separating units which are present here, they are called as the septa. And this is the placenta, and these are the ovules. Okay, these are the ovules, and the outermost layer here, these are the carpels or called the pistils. Now how do you describe such ovaries? So how do you describe ovary? Based on the number of carpels. Means carpel wise how to divide. First one I am giving you, first classification. If the carpel is single, it is called as monocarpellary ovary. Right? And if there are 2, it is called bicarpellary ovary. And sometimes there are 3 or multiples of 3, we call it as tricarpellary ovary. Means 3 or multiples of 3. This is only 2 or multiples of 2. Here it is only 1. This is 3 or multiples of 3. It is called tricarpellary ovary. Then pentacarpellary ovary. This is how divide the carpels or the ovaries based on the number of carpels. Now second classification is whether the carpels are fused, they have a common ovary wall, or they are separated. Second thing is based on the fusion of carpels. Okay. If the carpels are fused, first type is this. If they are fused carpels, then we call it as the syncarpous ovary. Syncarpous refers to fusion of the carpels. Second one, if they are free carpels, it is called as apocarpous ovary. Okay. These are the classifications of ovary based on the carpels. Monocarpellary, bicarpellary, tricarpellary, pentacarpellary. Based on the fusion, we have fused carpels as syncarpous ovary, free carpels as apocarpous ovary. You can see here this has 1, 2, 3, 4, 5 carpels, the pentacarpellary ovary, and this has 5 locules also. We can add locules also to this. It is called as pentacarpellary pentalocular syncarpous ovary. They are fused. Then the ovules are arranged. You can see here they are on the axis, exile placentation. You have learnt already in first PUC about the placentation. So I will not go to the details of placentation, although it is little mentioned in your book. Just understand whatever you have discussed already in first year, the same thing it is. The placentation is marginal or exile or parietal or free central, right? Or basal placentation. These are the placentations which you have learnt already. Here I am just giving you with that background that it is a pentacarpellary pentalocular syncarpal or pentacarpellary syncarpous ovary with 5 locules, and they are all fused. The ovules are located on the exile placentation, that is to the axis of the placenta. This is the structure of the ovary in section, right? Keeping this in mind, we are going to talk about the structure of the ovule. Okay, just draw this diagram, very simple diagram. Now students, let us go to the structure of the ovule. Ovule is the one which is attached to the placenta with the stalk, right? I will give you the diagram of the ovule in longitudinal section. So I will give you such a ovule which is observed in a vertical section. Okay, I am drawing the ovule. Okay, this ovule, whatever I am drawing, it is reverse ovule. We call this as an anatropous ovule. Anatropous ovule. Why this is called anatropous ovule? Because it is in a reverse way. It is the turned or bent ovule. How it is, I will just show you. Then other name also I will give you. So if you get the central portion, this is called the embryo sac. First I am drawing embryo sac. And surrounding this you find the membranes. This is one membrane I am drawing. This is the second membrane, the coverings. Then together they are going to cover this ovule like this. I hope you understood this. So this is reverse ovule. Okay. So what are the things? Here is one envelope, second envelope. Okay. First envelope, draw it properly. First envelope, second envelope. First and second envelope. Okay. This is the reverse ovule. This is called embryo sac. The whole embryo sac is turned 180 degree down, right? But normally this is a common type of ovule found. But in some, what happens is, this is the stalk. The stalk of the ovule is called as the funicle, and this is the embryo sac. This is embryo sac, right? But if you learn another type, you find the stalk like this and ovule will be straight like this, right? And here is the embryo sac with the membranes. Okay, this we call it as orthotropous ovule. The ovule, if it is straight with the funicle, this is funicle, this is funicle, this is the embryo sac. If embryo sac and funicle fall in the same line, it is said to be the orthotropous ovule. If the embryo sac is turned 180 degree down, bent ovule, it is called as an anatropous ovule. Right? Remember, they may be asking you one mark question, what is orthotropous, what is anatropous ovule. Now, let us talk about the parts of the ovule. Okay, this is funicle, and the part which remain attached to the funicle with the embryo sac, it is called as the hilum. And then these are the membranes. I told you the coverings are here. This is one covering, this is another covering. These are called as integuments. These are the integuments. They are coverings of the embryo sac. And this covering is not present in one of the lower area. You can see it is absent. It is called as the micropyle. Okay, micropyle is the area which do not contain any membrane, or the membrane is not covering the embryo sac. The opposite end of the micropyle is called as chalaza. Okay. So now I give another definition. If the micropyle chalaza remain parallel to the funicle, it is anatropous ovule. If the micropyle chalaza and funicle falls in the straight line, it is the orthotropous ovule. First, we should be in a position to distinguish between the micropylar end and the chalazal end. This area where chalaza is found, it is called chalazal end. The area without any covering is called the micropylar end. Okay, just understand this. This is before entering into the ovule structure. Right now, let me give you the details of this embryo sac. This embryo sac possesses number of nuclei and haploid cells. Right. The one present at the basal area is a large nucleus cell we call the egg. On either side you get synergids. Okay, what we call this one is the egg cell, egg, and the right side to them, right and left, these are the synergids or synergids on either side, here and here. Right, on the opposite side, so this is egg, the female gamete, and these are the synergids. On the opposite end, near the chalazal end, you get 3 haploid cells. These are called antipodal cells or antipodals. Okay, antipodals are the 3 haploid cells located at the chalazal end of the embryo sac. Then at the center of the embryo sac you find freely hanging nuclei. These are actually they are present with the cells only. These are called as polar nuclei. Okay. So polar nuclei are the central 2 nuclei which are haploid. They are freely hanging nuclei. So totally we will get 3 haploid cells, right? And polar nuclei, 2 of them are freely hanging here. Okay. Then this is the embryo sac structure. Surrounding this you find the nutritive tissue. We call it as a nucellus. Right? From here to here you get whatever you are drawing lightly. This is not very darkly drawing thing. You have to draw it very light. This is a nucellus. This also nourishes the growing embryo. Okay, this is the nucellus. Here till here I am drawing. Okay, this is nucellus. Okay, so this question is a 5-mark question to you with a labeled sketch. Explain the structure of anatropous ovule. And one more thing, here you can get the xylem and phloem conducting tissue. We call this as the raphe. Okay. So this is the total structure of ovule, anatropous ovule. Just you have to mention all the parts and explain the parts of it. So what all I told you in this, the ovule is a functional megasporangium containing a megaspore called egg or the ova. Right. This ovule is attached to the stalk, and stalk is attached to the placenta for drawing the nutrients in it. Right. Then the ovules are classified into 2 major types based on their orientation of the ovule with respect to the funicle. Funicle is the stalk, embryo sac is containing functional egg. Right? If the micropyle chalaza remains parallel to the funicle, because of the bending of the ovule of around 180 degrees, it is said to be the anatropous ovule. What about this orthotropous ovule? The funicle, chalaza and micropyle are in the straight line. It is called as the orthotropous ovule. So there are 2 ovules. The most common ovule is the anatropous ovule. Now we have to label the parts and explain the parts. First thing, the funicle, the stalk of the ovule containing it is attached to the placenta. Then hilum is the part of the funicle attached to the part of the body of the embryo sac. Raphe is the conducting tissue entering into the embryo sac. Then the whole embryo sac is covered on either side by outer and inner integuments. These are the integuments. The part which is not covered with the integument, the opening is present, it is called the micropyle. Even in the seed you can get small hole, that is actually micropylar hole. Micropyle is there. And its opposite end you get chalaza. Right? Chalaza is something opposite to the micropyle, because the chalaza end, this is called the micropylar end. And in the embryo sac, you get 3 haploid cells at the micropylar end, 3 haploid cells at the chalaza end. These are first one large egg cell, which is a functional female gamete, and 2 assisting cells called as synergids. You can see egg and synergids are written. Right? They assist in fertilization. Then at the opposite side you have antipodals, 3 haploid antipodals are present. At the central there will be 2 free nuclei present, therefore the polar nuclei. These are haploid in nature, N plus N. Okay, this is 3 antipodals, all are N in number, and even synergids are N in number, egg is N in number. They are all haploid structures, and this is the structure of embryo sac. Okay, then this drawing you have to practice. Right, now we pause and draw this diagram and practice it. Then we will go to the developmental stages. Okay, right, draw it. Students, today we are going to continue with the next part, that is already in the just behind this I explained you how is the pollen grain and how is the anther in section and how is the complete female gametophyte, that's an ovule, and types of ovules. Right? Now I am going to explain you the developmental stages of the microsporangia and microspores. This is called microsporogenesis. Then microgametogenesis, 2 words you have to remember. Microsporogenesis is formation of the microspore or the pollen grain. That is the sporangia. Microsporangiogenesis also you can call it. That is one pollen sac, we call it the microsporangia. Right? Then microgametogenesis, how these microspores are produced by meiosis. Okay? So we will now talk about the stages of anther development and microsporogenesis. So how anther develops and then how microsporo or microgametes will be formed. Okay. Let's begin with the first one. So whenever anther has to be formed, it will be a small oblong-like structure. Nothing will be there. Small outgrowth will be there, and that structure I have given you, somewhat elongated structure. Within this, you get actually all these are the kind of meristems or meristematic cells will be there. Meristems will be there. These meristematic cells will first undergo just one longitudinal division and differentiate as the outer layer as the epidermis, and inner one still remain as the meristematic tissue. Epidermal cells, the outer one cells, the covering cells. Then this inner cell meristematic cells which are near the epidermis undergo periclinal division. Periclinal is horizontal division, anticlinal is longitudinal. See, biological, whenever we talk about botany, the terms are different from zoology. In zoology, when we were talking about cleavage, I said meridional plane and the equatorial plane. But here it's not so. The divisions happening longitudinally are called anticlinal divisions, and those happen in the horizontal way are called as a periclinal divisions. So remember these words, whenever the anticlinal or periclinal word comes, it must be connected with plant development or plant tissue development. Okay, so first there will be periclinal division and there will be 2 cells formed. One is outermost epidermis and inner one called the inner primary sporogenous cells. So this structure, you can see some dark cells here. These can be called the archisporial cells. They become darkly stained or they will have the thicker nucleus, larger nucleus. Next is this, whatever archisporial cells are there, they undergo periclinal division, periclinal transverse divisions and form 2 layers. Outer layer is called the primary parietal cell layer and inner one is called the primary sporogenous cells. So 2 types of tissue cells are formed. Outer ones which undergo transverse division Outer one, whatever is formed is called the primary parietal cells, and inner ones, whatever are formed are called the primary sporogenous cells. Understand this, right? This is a depth for the NEET and all, it will help, because after this, if we, as I am discussing Transcend or any other books which are connected with NEET syllabus, that time you need such depth. Therefore, I am going to the depth of development of the microspores, right? So once it is forming two layers, outer ones, whatever they are there, these are forming the covering cells, covering layers, and inner ones, they are form the sporogenous tissue or microspore future mother cell. Okay. Then the fourth, you can see here A, B, C, D. All are the four diagrams representing the developmental stage, initial development of the microsporangium. You can see here. Now, so the outermost parietal layers start dividing anticlinally and periclinally. You can see here I am saying the word anticlinal and periclinal, and forming some outer coverings of the microsporangia, and the inner ones are called the primary sporogenous cells or sporogenous tissue. It's called sporogenous tissue. They are distinguished from the others by having thicker and darker nucleus. So as I am showing the diagram, earlier it was slightly oblong in shape, slightly it starts enlarging in size. It forms almost like a tetragonal structure or a square-like structure, and now you can see clearly at four places, four sporangia develop. 1, 2, 3, 4. They are called microsporangia. They are going to become microsporangial initial cells or microsporangial cells. Right? These are the first stages. After this, I will be showing you how this will enlarge and with the help of detailed structure. Right? The diagram E, it explains stages of the developing anther. See the words, the question they will ask you. Draw a neat labeled sketch of developing anther, means you have to write this. But developed anther means pollen grains are already released. Therefore, this is a developing anther. It is on the way to develop. Okay. So how the cells are dividing there? Outermost layer becomes flat cells. It forms epidermis, and it will divide first periclinally and forms number of elongated cells. This is forming the endothecium. Endothecial cells are distinguished by having some elongated marginal linings inside this. This is an endothecium. This will give mechanical protection for the microsporangium. Then comes the middle layers are distinguished here. These are called the middle layers. Okay. But some of the cells which are inside, you can see some of them from the walls only, parietal cells only, they distinguish to have multinucleated condition. You can see here multinucleated, elongated, larger cells are formed. This forms a tapetum. You can see here, this is the endothecium and this is the middle layer. These are the middle layers, and this is a micro. Inside whatever you got dark nucleated and very prominent nucleated cells, they are all called the microspore mother cells or MMC. They are going to become undergo meiosis to form microspores. Microspore mother cells are always diploid in nature. Now, one more thing I can show here. Here slightly elevated portion is there. This is the area where there will be connective. Connective actually brings the vascular tissues or vascular bundle in this area. This is a vascular xylem and filament will be there. That's a connective. Already I showed you the filament and a connective and the two anther lobes. This is the connective. Then there are other four microsporangia. This one microsporangia I have enlarged. Like that all the four will be there. But you can see something different here. Whatever I drawn here, the corners wherever it is, they will be actually slightly enlarged cells. They are elongated, thin wall cells are found. This in short, the small portion I have enlarged here and showed you here. Observe it. Here you can see epidermis, all cells are somewhat flat cells, right? These are epidermal cells. Then this whatever I drawn inside, this is the endothecial layer. You can see it is elongated, some thickenings are there on that, right? These are the endothecial cells or endothecium. There are 2 to 4 micro, because the middle layers, around 3 or 2 to 3 middle layers are formed. They are going to disintegrate later. Then comes the tapetum. You can see tapetum. Tapetum cells are different totally from the remaining cells. The cells are having multinucleate condition. You can see so many nuclei are drawn. This layer is called tapetum, right? This is the tapetum. Each one is a microsporangia. This I will label it as tapetum. Tapetum is that way multinucleated and it contains a lot of nutrients and vitamins and growth hormones in it. Why? Because it will give the nourishment for the microspore mother cells. Microspore mother cells, when the meiosis, then the nourishment will be given by tapetal cells. Tapetum. See, in detail I am explaining you. This drawing is better you just keep it with you. Just take a screenshot and keep it. Anyway, you need not to draw in details. But anyway, this drawing will be asked, and mature the anther also will be asked. But developing stages, you just take a screenshot and keep it with you. Whenever you get doubts, you can go through that. Okay, how it has developed, because always developmental stages are very important for you to understand how the shape had changed. See, the shape was like that. Slowly it became triangle, triangle to quadrangle. Then slowly it became almost square-like, and upper and lower totally 2 anther lobes with the 4 microsporangia are formed. Right? These are the microsporangial mother cells or microspore mother cells. I'm sorry, microspore mother cells that are diploid in nature. But you can see the epidermal cells which I used to draw earlier. You can see here they were all flat cells, right? Epidermal. But here when it comes to the corner, the cells become thin walled. This is called as the stomium. Remember the word stomium. Stomium is a lightly thin layer which actually the very weak point. Whenever there is a stimuli, at this point the complete anther will break, right, to release the pollen grains. That I will show you in the next diagram. You can see the next diagram here. This is the tears of mature anther liberating the pollen grains. Completely they are liberated. You can see here the complete all the things are there, and slightly middle layers are getting distinct. They are getting utilized or they are getting removed. Then slowly at the area of the stomium, it has been broken down, right? This is stomium having thin wall cells, it got broken down and the pollen grains are released. These are all pollen grains. They are undergoing meiosis. They are after meiosis these are formed. They are haploid in nature. They come out. This is during the maturity. So all the layers are there, but what a major thing happening is at the stomial layer it will break. This process of breakdown of anthers to release pollen grains is called anther dehiscence, or we call this as anthesis. Word you remember? Anthesis. Anther dehiscence. Listen, actually you will be doing an experiment on this actually, whether it is, it's a meiosis, to study meiosis. The practical part is there. How to know, how to study the metaphase, anaphase or telophase stages in mitosis, you take a root tip. But for studying meiosis, you have to take the anther, pollen grains you have to, or the anther section you have to do. Right? Normally it can be done in your Rio leaf or even in your Allium cepa, that's onion. That time, anther dehiscence actually is very specific. See, actually plants are so beautiful that they have the arrangement within themselves. They have all timetables when they have to dehisce the anther. Only they dehisce the anther when there is proper wind, and the female structure will have to grow. Then only they will release the pollen. It's a very important thing for you to understand, because plants, most of us, we hardly give any value for them. Even my students say that botany is not interesting at all. But you really have to wonder that how beautiful is botany, that the plants are doing so many activities without our knowledge. The example are the real confirmation test is you will get fruits at the right time. Like mango season, mangoes will come. Right? Whatever season fruits are formed means pollination has happened, flowers were formed, pollination happened, fertilization happened, then the fruits were formed. So that is the beauty of nature. Right? You have to understand all this. Because of this understanding, you will get really, at least get interest how the things are happening in nature. Instead of simply what we do is, okay, this is one, okay, this much I will study, this much I will get mark. That is different. That's like just like a business minded. But I want you to keep wondering about the natural things, and somebody have worked on this actually. Vigor Swami and all they have worked on. I hope you have heard about Vigor Swami. Vigor Swami is the only Indian botanist who actually was not only, he was from Karnataka, only Karnataka botanist. He was a son of DBG. He has given a lot of papers on this. He has done a lot of research on the embryo development in plants and development of the megaspores. Everything he has worked on it. So at least give some respect to them. Learn how they would have worked, because they would have been there in the lab from years together, right? This you will not come one day, okay, how it is happening, I am showing you the drawing, you just copying the drawing, write this, getting marks. No. To learn all this, you have the person have to patiently wait there and understand how these things are happening. Time to time they have to, with the time span, they have to understand how much they are growing, at what time anthers are dehiscing, because it differs from plant to plant. Remember this, because plants you will be feeling that all pollen grains are in the air, okay, any pollen grain will pollinate, even though this will never happen. If you think of pollen grains or the Allium cepa, it will release the pollen grains around 9 to 10. At that time they are released, at that time other plants will not be releasing pollen grains, but mostly in that duration most of the pollen grains are released. Therefore, whenever you want to learn meiosis or to study anther showing the development of microspore, then you have to fix the anther at the time, normally around 9 to 10. This I would like to tell some of our lecturers also, teachers also, those who want to fix the anthers, because they want to show meiosis to children. Then anytime you bring the flower and observe, you will not get any stages, because meiosis you should get meiosis 1, meiosis 2. In meiosis 1 you get prophase 1, prophase 2, prophase 1, metaphase 1, telophase, anaphase 1, telophase 1. Under metaphase 1, prophase 1 you have leptotin, zygotin, packaging, diplotin, dikinesis. So connect the subjects, okay. So don't just think that okay, this much is subject, okay, you learn this, you will get the mark. Marks you will get anyway. If you know the subject, any type of question comes, you will be able to answer. Therefore, understand that anther dehiscence is an important property of the plants, and once it dehisces, pollen grains are in air. The pollen grains are surviving so long, years together, thousands of years together, till today we are getting the fossils of only pollen grains. So beautiful they are. Why? Because they are having some resistant material called sporopollenin. Pollen grains, I told you, exile will have sporopollenin that is so resistant either to acid or alkali, it will not dissolve. Therefore, till now whatever we get or we are observing evolutionary pattern is because of the pollen grains only. You take the pollen grain fossils and understand this was at this time it was existing. So we can understand, okay, at this particular time these were there, these kind of plants were there, how they modified, when gymnosperms originated, when angiosperms originated, everything. We are studying the evolutionary pattern based on the fossil availability of pollen grains mainly. So understand, this is a beautiful thing to understand. Not only beautiful, it is having so many work behind, so many people are working behind it to give you this kind of pictures. That's why I drew it before. You need not to draw it, but just I drew it before. I wanted to show you this. In front of you I did not draw, because this drawing they will not ask you, but you are supposed to understand step by step how it is happening. So I want you to keenly observe every part, and if you really get some doubts, so please ask me, because I have seen students only hardly 1, 2, 3 people are asking me continuously, but I want you to really get involved in it, because most of us, we think human reproduction is very interesting. Lot of questions will be appearing. Most of the students will ask how twins are formed, when the head of the baby will turn. Those questions are very common questions. Many of us will get it, because it is connected with human beings. But about the plants, you have to work, because without them we are not there. Therefore, learn about plants and their growth and their development, how they pollinate, how they fertilize. That's a very nice chapter. You have to learn it. And not only this, because it's almost everywhere, people don't write botany questions. Mostly they say that, oh, it's very not interesting. But you people learn it, it is really beautiful, right? And I will make you understand each and every step in this. Then you will feel it's very easy, and very easily you can answer for almost all MCQ questions also. Okay? So go through the drawing some more time and understand this. Okay? Then. Okay students, now let's continue with the development of the pollen grain. Pollen grain, I told you, it is a microspore. So before this, some small thing I'll give you. the microspore mother cell, how it forms the microspore. That is, before this pollen grain germination happens only when it is released. So just one more thing I would like to give you, that is the development of microspore from microspore mother cell. So imagine this is a microspore mother cell, MMC. I have drawn it. It is diploid in nature. Microspore mother cell undergo first meiosis 1. Okay, meiosis 1 will result in formation of dyad, we call it. It's a dyad cell. It's a dyad. Okay, and dyad becomes haploid. Okay, because it is undergoing reduction division. Then in meiosis 2, 4 cells are formed, but they are arranged like this. One is the first one, second one, third one. They are arranged like this. Okay, and here are the nuclei arranged. This is actually called the tetrad. Here is one nucleus found, here is one, other side is another. This is called the tetrad. Here these tetrads means having group of 4 cells. One is other side. Okay, these are the n number haploid, but having 4 haploid cells. Then it will combine with having 4 of them, all of them they combine together in one single common area, and this forms the tetrad, pollen tetrad we call it, and they separate off, right? They are held together. This is the tetrad, pollen tetrad with the fully formed pollen grains. They can separate it, they will separate here. Now the pollen grains, when they are released, they are of different shape. They may be of this shape with exine and intine, or they may be rounded, but anyway in one there are totally 4 haploid microspores are formed. These are the pollen grains. These are the pollen grains. This is called as the pollen tetrad. Tetrad means having 4 cells held together. So this is the microspore development from the microspore mother cells. Formation of microspore from the microspore mother cells. Microspore from MMC. Right? This is the structure. You remember. And this drawing you will have to. They'll be asking you. Write a note on microspore development from microspore mother cell. Microspore is nothing but the pollen grain. Okay, just remember, first it will undergo meiosis 1, only 2 haploid cells are formed, then undergo meiosis 2, form 4 haploid cells, then they held together forming a pollen tetrad, then they separate to come out as a pollen grains. Pollen grain maybe it is round shaped, they are triangle shaped, any type of shape you will get in the pollen grains. Okay, so just understand this. I will now move on to the next one. Then how that is about the how pollen grain germinates. This is the formation. It is a developmental stage. But germination is when the pollen grains are released. How many cells are there in that? When they pass it to the stigma, how they are growing. Right. So let me give you that part. Just draw it. Just draw it. You can understand. It's simple drawing. Okay. Now I will give you about the pollen germination. Pollen germination or microspore germination, right? How exactly it will germinate. So let me draw one pollen grain. This will be a bigger pollen grain I am drawing. One pollen grain. And I told you its exine is highly designed and sculptured. Right? Already I have discussed with this. I will not go to the details of this. This is the exine, this is the intine. Right? This is the exine, sculptured one. Inner one is the intine with number of germ pores, or these are the germ pores. Right? These are the germ pores. And it is a haploid structure having the paternal set of chromosome. This is one pollen grain. Okay? Pollen grain. Now, how exactly divisions take place? So first, this structure, pollen grain, internally it starts dividing. So this is the structure again. Exine I am drawing. Exine I am not giving much importance because already I have explained this. See, whenever you are explaining something, particularly when you are narrowing down the subject, that other things will be understood because they are already explained. Now only I am concentrating on the inner part. So this male nucleus, so whatever I draw, this is the male gametic nucleus, which is haploid nucleus. Now what happens? This will undergo a division. One of the unequal division happens. One of them will be a very small cell formed, and one will be the large one with all the cytoplasm and nucleus. The smaller one formed will be almost attached to one corner of this. This is called as the generative cell, and this is called as the vegetative cell or nucleus. Because this nucleus is generative nucleus, this is the vegetative nucleus. First it is simple mitotic division, two cells are formed, one is very small, one is large one. Now, next what happens is this generative cell comes out from the attached portion and it starts floating in the cytoplasm of the vegetative cell, right? In this cytoplasm, there will be generative cell start floating here. Vegetative cell also is here. This is the generative cell, small lanceolar, means the lens-like structure. This is the generative cell. This is the vegetative cell or nucleus or cell, right? Nucleus is its nucleus. Now, how it will germinate? This is called as a two-cell stage. Normally at two-cell stage, the pollen grains are released from the anther, right? Not only after undergoing meiosis they are released. Normally the stage in which they are released or anther dehiscence take place is the two-cell stage, right? Now what happens further? So further it start developing or growing. If it will get released, it will go attached to the stigma and it may start germination. So what happens next is, suppose this is the pollen grain again. This generative nucleus, actually generative nucleus is going to form the male gametes. Now it will undergo one mitotic division and form two such lanceolar male gametes, right? And this generative nucleus is already there. So this is a three-cell stage. These are the two male gametic nuclei or gametes or gametic nuclei, and this is the generative nucleus. Because they don't have right now properly cell around them. Now at this stage also in some of the plants the pollen grains are released. Pollen grains are either released at the two-cell stage or they are released at the three-cell stage. But what happens further, I'll give you. Just observe now this, what happens with this. In time, from the germinal pore area start germinating or protrudes out, right? When it reaches the female structure, this outgrowth or tube-like structure is formed. This we call it as the pollen tube. Pollen tube, once it is formed, the two male gametic nucleus along the vegetative nucleus will enter into this. The two male gametic nucleus and this is the vegetative nucleus. This is the vegetative nucleus. These are the two male gametic nuclei. Okay, and the cytoplasm start pouring into this. Okay, this is the formation of pollen tube during germination. Later, this germination continues and the pollen tube will enlarge. Right, pollen tube may enlarge like this. It may go straight, it may go side, anything is fine, right? But the slowly generative nucleus disintegrates and the two male gametic nuclei will survive. These are the male nuclei. This will penetrate into the style and reach the egg. So this is the germination of the pollen grain or pollen germination. Very important drawings these are. These can be asked as a 3 or 5 mark question to you. Write a note on germination of the pollen grain. So you need to draw all these diagrams and explain just one line. First, pollen grain is having this exine. Exine is made up of, already I told you, exine consists of sporopollenin and it is highly designed, sculptured, it may be spiny, it may be having some fibrous like thing and all. Then each pollen grain has exine and inner thin and smooth intime. then a male gametic nucleus which is haploid. Now during germination, first division is happening mitotically, but nucleus will divide into two. One becomes a generative cell or this nucleus, it is attached to one side, so we can call this as cell also, generative cell, and this is called the vegetative nucleus because it is found in the fluid like or protoplasm. Cytoplasm will be floating. Now next stage, this generative nucleus or the cell, whatever was there, it will separate from the periphery and start floating in the cytoplasm along with the inside the vegetative nucleus. Now this generative, let me write properly, generative cell or the nucleus, right? This is floating inside this. Now this generative cell or the nucleus, cell because it has a very thin cell membrane, otherwise you can call it generative nucleus also. Generative nucleus undergo another mitotic division and form two male gametic nuclei. And one generative nucleus is already there, this is generative nucleus. Now the two male gametic nuclei, this is a 3 cell stage, this is the 2 cell stage. Now after this, generative, the whole thing, the pollen grain will show the development of small outgrowth, protruded through the germ pores actually. The exact openings are called germ pores, through which it is released. In that, vegetative nucleus also enters, the two male gametic nuclei also enter into the pollen tube. Now pollen tubes start elongating, during which the generative nucleus disintegrates and the two male gametic nuclei will survive. These are going to pass, the pollen tube is going to pass into the tube of the style in the female and pass the two male nuclei into the egg apparatus, and they bring about the fertilization. Right? This whole story you remember as a germination of pollen grains. Okay? This drawing also is important. 5 mark question you may get, 2 mark question you may get. But structure of the pollen grain is a 2 mark question, and drawing with explanation is a 5 mark question. Okay? And separately they may ask you what is generative cell function, what is the function of the vegetative cell, which is the larger nucleus, larger cell compared to the in the pollen grain. Larger is always the generative nucleus. So once you have finished about the microsporophyte development or formation of microsporangia and microspores, then the other way you have to understand that there will be another type of division stages for the formation of megasporophyte also, or megasporophyte, or normally we call the ovule development. So already ovule will be, within the ovule there will be some undifferentiated cells from where the megaspore will start growing, right? So what I have drawn here is the first structure. All these are undifferentiated cells. We can call them as nucellus. Actually, nucellus in the undifferentiated cells, one of the cell will become very prominent with a prominent nucleus and dense cytoplasm, and this is called a megaspore mother cell or megasporocyte mother cell. You can also call the megasporocyte or megaspore mother cell. This is diploid. All these are diploid in nature. There are certain stages in some of the plants. These nucellar cells, without undergoing any meiosis, they can form the complete megaspore or the embryo sac or the egg. That kind of condition we call the apomixis. Without formation of the, or without undergoing any meiosis, diploid cells of the nucellus will form the egg, or in future the seed also. We call this as apomixis. So without any fertilization, nothing is happening, no meiosis also, diploid thing will grow. In the last part of this chapter I will explain you again apomixis, but right now you should understand from where exactly these will undergo apomixis. So all these cells of the nucellus are diploid in nature, along with megaspore mother cell is also diploid. Megaspore mother cell is differentiated from one of the nucellar cell only. Nucellus is undifferentiated, we call it the meristematic tissue found in the ovule, right? Complete gynoecium you understood, ovule, in that, the ovary, in that you get lot of tissue. It is called, normally it is meristematic, it is division tissue containing dividing cells. It is called the regular meristematic tissue. Now one of them will get distinguished from the rest of the nucellar cells. This we call it as a megaspore mother cell, which is diploid in nature. Now, this megaspore mother cell undergo meiosis 1. You all know mitosis meiosis knowledge is very important from first PUC. Mitosis is a simple equational division, you know. Now I am saying the word meiosis. Wherever the gamete formation happens, there we have to learn about the meiosis properly. Meiosis, as we already discussed, there are two stages, meiosis 1 and meiosis 2. In meiosis 1, there will be actually reduction division happening. There will be formation of haploid 2 cells. We call them as dyad. Dyad is having 2 cells together. Two cells arranged together. It is called the dyad because meiosis 1 itself is a reductional cell division. Right? Therefore, here already the diploid cell, whichever I have drawn here, the mother cell will undergo meiosis 1, form 2 haploid cells, that is forming a dyad. Now, meiosis 2 will happen. It is actually called as a simple mitotic division. You already know that. Meiosis 2 is just mitotic division. There is no change in the chromosomes. Already it has become haploid. Now, simply it will form 4 cells. They are all haploid in nature. So, this is forming a linear tetrad. Each cell is a n number, right? These all are the 4 haploid cells formed, arranged in a linear sequence, right? Now, from here, the development will change. In some of the plants, all the 4 will differentiate to form a megaspore. It is called as the tetrasporic embryo sac. Sometimes only 2 will grow, 2 will disintegrate. It is called the bisporic embryo sac. Understand this thoroughly. It's a neat question. Right? But very common one is the upper 3 will disintegrate. Upper refers to the chalazal end, because at that same time when this is happening, the 2 integuments also start growing from the cells of the ovary. Then the upper part of the complete ovule, there will be chalazal end. From the chalazal end, 3 of them will disintegrate. Only one, which is at the micropylar end, will develop. Therefore, we call this as the monosporic embryo sac. Monosporic embryo sac. Very important it is. This is the only thing mostly students undergo confusion. They think that okay, this what is this, we never learned. Therefore, when I am talking about this only, I am explaining all the different types also. So, types of embryo sacs based on the development is 3. One is tetrasporic embryo sac. All of the 4 of them will develop into embryo sac. Bisporic, upper 2 will disintegrate, lower 2 will continue to grow. Monosporic, which is very common, where upper 3, those who are at the chalazal end, will disintegrate and lower one will become the functional megasporocyte or functional megaspore cell. This is haploid in nature because already all of these are haploid only because they undergo meiosis. Now, haploid cell is formed. This is called the functional megaspore of the embryo sac mother cell, they call it. It's an embryo sac mother cell. Now, how exactly embryo sac will be fully formed from that embryo sac mother cell? So, this cell I am continuing with this here. So, this is a megasporocyte which is having haploid condition because already it has undergone meiosis. Now, next stage is how embryo sac develops is there are free nuclear divisions taking place. It is not undergoing the cytokinesis. Remember, whenever I say free nuclear divisions, the karyokinesis is not followed by the cytokinesis. I hope you know the difference between cytokinesis and karyokinesis. Cytokinesis is nothing but the division of the cytoplasm. Karyokinesis is the division of the nucleus. Most of the conditions, always karyokinesis is followed by cytokinesis to form the 2 daughter cells. But here only free nuclear divisions are taking place. So first time it undergo meiosis 1. The nucleus, which is haploid in nature, form 2 nuclear states. This is a 2 nuclear condition. Then again each of them, they will go to 2 different poles. Each of them undergo one more mitotic division to form 2 cells at the chalazal end, 2 cells at the micropylar end. Then again on 3rd meiosis, totally each end or each pole 4 haploid nuclei are formed. This is a 8 nuclear stage. 8 nuclear stage. This is the 4 nuclei stage. This is 2 nuclei stage. right? Like this, free nuclear divisions are taking place without the formation of cytoplasmic wall or cell wall. Therefore, only 4 haploid nuclei are present at the upper chalazolen. Lower micropylar and also contain 4 haploid nuclei. Now the rearrangement of, see, rearrangement, these nucleus undergo arrangement, and upper area 3 cells will be formed. These are called antipodal. See, the nuclei are brought with the cell membrane, cell wall. This is the antipodal cells, which are 3 in number, and lower side one of them will be very large, forming the egg, which is the female gamete. Then 2 sidewise cells will be there for the egg, they are called as the synergids. Then one from each pole will move to the center and form 2 free nuclear conditions. They are freely suspended at the center, they are called as polar nuclei or secondary nuclei. They are N plus N. So we have 3 cells in the chalazolen. This is the chalazolen. The 3 cells at the micropylar end and 2 free nuclei are present in the center. This is called the completely developed embryo sac. Okay, the fully developed embryo sac should have all this. And these membranes, I told you, these are the integuments which will not completely formed around the whole of the embryo sac. They will leave the gap. That gap is called the micropyle. Opposite of the micropyle is called as the chalaza. And these are the half developed integuments. And there will be one more thread-like thing I have drawn here. This is called the filiform apparatus. They are thread-like structures, almost like channelized structures or feathery structures. These actually help in guiding the male gamete towards the egg. Right? Whenever the fertilization happens, male gametes are released in the synergids, and these will guide the male gametes to move towards the egg. That is the important function of filiform apparatus. And lower all the 3 things, that is egg, 1 egg with haploid condition plus 2 synergids. Together, along with the filiform apparatus, we call this as the egg apparatus. Egg apparatus means the whole thing. Right? All these together from the egg apparatus or egg area. Right? This is the functional structure. So remaining all over here, whatever you get here, it is the nucellus, which is the nutritive tissue for the growing embryo later. Okay? So this structure is very important. This is given in your NCERT book also. Details I told you, monosporic, bisporic, tetrasporic embryo sac, it is in neat portions. Otherwise, these structures are already given in your book, or if drawings are not there, at least explanation in 2 lines are given, but I have given in detail so that you should not have any confusion with this. Drawings, again I told you, screenshot them, try to draw this. This is the drawing which may appear in examination. Megasporogenesis or formation of megasporocyte, formation of the embryo sac. This is different, this is different. This will continue with the next diagram. So if you want to label, this is the first diagram, this is second, this is the third diagram, this is fourth diagram, formation of megasporocyte. Then this will be fifth diagram. Sixth diagram include 1, 2, 3, all pre-nuclear divisions. And last diagram, that is the seventh diagram, is the formation of fully developed embryo sac. So all the diagrams you are supposed to know. You will be wondering, so many drawings are there, but they are not very artistic diagrams. They are just technical diagrams. Only you have to mention properly the name of those cells. So if at all I am here, you may not be able to see the whole screen. So I'll just separate, I'll just move out, and I want you to take the whole diagram, its screenshot, and draw it, practice, or else pause it and practice drawing. This drawing will appear in the examination, right? Even NCERT will appear in the regular NEET examination. You will get any developmental stages. What is the, after first meiosis, how many cells are formed? What is the dyad? What is the linear tetrad? Everything they will ask you. So every 1 mark question is understood only when you understand the complete story of the subject. Don't think that 1 mark different from the 5 mark. If you understand the whole story, then 1 mark and 5 mark are same for you. But only thing is you have to know everything in detail. There is no shortcut in studies. Okay, so you have to learn it in details. Then you can learn, or you can write either 1 mark or 2 mark and try to draw it, practice it, and explain to somebody or keep writing explanation, because mostly biology examination in board, what problem happens is our students will not get time. Why? Because they have just read the book, read and just gone through the diagrams. No, you will have to take the pen, pencil, eraser, everything, keep drawing, keep writing the explanation. This is the right way to score 100% in board examination. And while writing all this, you will come to the whole story of this. All the depth itself is a neat portion. Okay, there is nothing that separately you have to study for that. Under this one will come. If you understand this thoroughly, any neat question you will be able to answer easily. Okay, then go through this. Okay students, we are now continuing with the next part. Till now I have to explain you about how are the male and female gametes developed or gametophytes are developed. Now what is next is how exactly the male gamete will pass to the female gamete. That is pollination. Pollination is the transfer of male gamete, that is pollen grain, from the anther to the stigma of the gynoecium. So how are the pollination distinguished? Right? First one, it's called cell pollination. What is the meaning of this? Suppose this is one plant and here there is one flower, right? There will be flower. So let me draw the gynoecium and androecium, okay, anthers and gynoecium. If the flower pollen grain falls on its own stigma, it is called cell pollination. Means this is gynoecium, this is androecium or stamens. If the pollen grains of the same flower falls on the stigma of the same flower, we call it as self pollination. We call this also as autogamy. Auto refers to self. Gametes are self. But the other one is called cross pollination. This is nothing but allogamy. What happens is, here suppose there is one flower, stigma, anthers, okay. There is another flower, it has the stigma, anthers. If the flower's pollen grain of one plant or one flower falls on the stigma of another, it is called as cross pollination. Or this falls on this stigma also is cross pollination or allogamy. So differentiate between self and cross pollination. What is it? It is a transfer of pollen grain from the anther to the stigma of the same flower is called as self pollination. And if the pollen grains of one flower transfer to the stigma of the another flower, it is called as a cross pollination, or there will be allogamy. Now what is the other difference? What is the use of self or cross pollination? One more thing I would like to give you now only. If suppose there are two flowers in the same plant, okay, here is one flower, here is another flower, okay, stigma, anthers, calyx, corolla I am drawing. If the pollen grain of this anther of one flower, flower 1, flower 2 of the same plant falls on the stigma of the same plant's another flower, it is called as gytenogamy. Understand this thoroughly? This is gytenogamy. What is that? The pollen grain of one flower of the plant falls on the stigma of the another flower of the same plant. It is called gytenogamy. Other one is this way. This is plant number 1, this is plant number 2. Suppose the pollen grain of one flower transferred to the stigma of the another flower of different plant. It is called as xenogamy. Okay. Cross pollination can be this way also. Transferring pollen grain from one flower to another flower is same. It is called cross pollination. But xenogamy is one plant's pollen grains fall on the another plant's the stigma of another flower. That is called as the xenogamy. So self pollination is transferring the pollen grain from the anther to the stigma of the same flower. Cross pollination is transferring the pollen grain from the anther to the stigma of the another flower, right? Then xenogamy and gytenogamy you learned. Now we will learn why exactly plants or what are the characteristics of self-pollinating plants and cross-pollinating plants. If you understand that, then you can easily analyze why some flowers are colorless, why some flowers are without any smell or perfume, all that, right? So this is the way you have to analyze the nature. Whenever you see any flowers, any plants, then you will have to wonder, how come one plant is showing so beautiful flowers like champaka flower or your jasmine flower. They are so nicely smelling. Some of them, they will not at all smell. So what is the reason? That's mainly because mostly the characters are like that. If you think of self-pollinating flowers, then they do not have to depend on any external agency for the transfer of pollen grains. Okay? Why? Because they will be transferring from their own stigma to their anther. The anther will transfer the pollen grain from its own into the stigma. Right? They don't need any external agencies, and so many times these are so tall, they will fall directly on this. Right? This is called self-pollination. For this reason, self-pollinating flowers don't have attractive color, they don't produce nice smell, they don't have nectar. Sometimes they may have nectar also, but mainly they don't have much nectar. Why all these three things are required is to attract the external agencies to help in pollination. Therefore, cross-pollinating flowers, imagine if you talk about cross-pollination, then these flowers should have very attractive color, they should be colorful, they should be having certain smell or perfume, or they must have nectar. These are the basic requirements for cross-pollination. Why? Because if the pollen grain is formed in one flower, it has to transfer it to the other flower. Who will do that? There should be some agencies, right? Those agencies normally available are either wind or insects or birds. Mainly insects and all will get attracted to the flowers only if the flower is attractive. Otherwise they will not even have that job of searching where is the flower, let me pollinate. That's not their work, okay? Most of the students think that way. Insects are born to pollinate flowers. No. Insects will be moving around to collect the nectar like honeybees and all. And if they want to collect nectar, they have to locate where is the flower. Right? Like how we want to go in some place to some place, we want to look at through the Google map. They don't want Google map. They will have their own ways to identify the flower. Why? Because both of them are mutually understanding each other. Such flowers who want to get pollinated by the insects, they will attract them by producing beautiful colors or nice fragrance. Sometimes may not be very nice fragrance. It may be attractive to the insects only. Right? And insects get attracted by sometimes bad smell also, right? And nice nectar. So nectar will be like a gift for the coming vector. Means gift should be given. Suppose one insect comes to search, the flower is very beautifully colored. It comes in because of the color. And if there is no nectar there, there is no gift, then next time it will not come. Very nice, no? If you go to somebody's house, they will say, okay, you come, I'll do this, I'll do that. Okay, you go there, they don't give you anything, and you feel very hungry, you come back like that. Next day, whatever they do, you will not go. So insects are also like that. They want some kind of gifts for them. That gift given by flowers is normally nectar. So therefore, the flowers which undergo cross-pollination must have to get attraction, or they produce something which is attracting. That attracting thing should attract the insects, right? Therefore, they should have beautiful color, they should have nice perfume, they should have nectar. Now, what is that color thing? I told you, normally the insects get attracted by yellow color and red color, right? Red color attract the insects more. And next is yellow. Other colors, okay, most of the time the insects will not identify the other colors. Right? Therefore, mostly reddish, orange or yellowish, red and all, they will have colors. Right? Perfume, I told you that perfume is produced, it may not be like a champaka flower. Michaela champaka has beautiful smell, right? Nice smell, everybody get attracted. But there are some flowers which will produce very bad smell, right? Like a rotten meat. Did you get what is that? Its name is Rafflesia arnoldi. What is this? Rafflesia arnoldi is the largest flower in the world. Almost when it opens, it is few meters in size. Therefore, this is the largest flower. You know why I told you about this? Because it produces a kind of smell which is like a rotten meat. Rotten meat is very bad smell. Actually, when it was discovered, it was a very interesting story there. When it was discovered, long time people, it was in the Jamaican forest somewhere. Then there was always that smell of rotten meat. Most of the people who want to hunt and all in this forest, if they get this rotten meat smell, they will not visit there because lions and all will eat the rotten meat. So they used to think that this smell indicates there is a presence of lion there. Therefore, many days, many years, nobody understood what is this, why the smell is persisting for a long time. Then Arnoldi, scientists identified that there is a huge big flower which is named after his name, Rafflesia arnoldi, and that is attracting so many insects. Almost millions of insects are forming almost like a nest inside that. So therefore we call this as a queen of parasite also. So many insects are there in that. So anyway, that's a very nice thing to learn about the perfume also. All the time perfume means don't think you have beautiful smells, nice fragrant smells. Sometimes bad smell also attract insects. Right? Then nectar. You know, mostly the honeybees and all, they go for the nectar, which is a sweet content. So if you observe the flower, suppose this is the flower, here is the gynoecium, imagine, okay, here is the anther, and the petals are like this. In this area of the petals, normally nectar is secreted. So while entering into this, the insect, suppose it's entering into this, it will have to cross the pollen grains and anthers. And when it comes here to have the nectar, while going back again, all your body, its body will be fed with the nectar, the number of pollen grains. And when it visits the next flower, then while moving down, it will transfer the pollen grains. Therefore, insects always like to get attracted by such beautiful colors. Right? So those are the characteristic features of cross-pollinating flowers. And one more thing, if the petals, normally petals are attractive in nature, you know that, right? Hibiscus, rose and all petals are very attractive. But in some flowers like bougainvillea, you are seeing bougainvillea having the papery flowers, right? In that, flowers are very small, minute white colored. Just to attract the insect, the bracts become beautifully colored like pink and somewhat creamish color and all. Therefore, always plants will give one future look. Okay, let me get the attractive thing. How to get attraction? If the petals are not colorful, something else get colorful. Like in poinsettia, bracts are becoming colorful, or some lower leaves get attractive in color. So like that, their main purpose, like life sciences, the main purpose of life is to produce offsprings. Every organism will be always busy in reproducing, including the plants, because this is nature. Right? They first attract the pollen grain, the insects and all, then pollinate. Right? Now some important things about self and cross pollination, let me explain you. One thing, self pollination. There are some flowers that undergo 100% self pollination. Right? Example is Camelina. In this plant, flowers remain closed. Right? If this is the anther and this is stigma, petals almost cover this. Like this. These are the closed flowers, right? This is compulsory self-pollination happens in such closed flowers, right? These are, but when the flowers are open, these are called as chasmogamous flowers. These are the open petals. They undergo pollination by insects or air and all, right? These are closed flowers. The flowers which are closed flowers, it is. These flowers are normally getting pollinated only by the self-pollination. Right. Now coming to this self-pollination characteristic here. As the petals and other things are not coming, for example, you know grasses and all these rice and wheat and your ragi and all, they have greenish or yellowish green petals. So nobody will know that they will undergo pollination or fertilization also. But still you can see the seed setting, yield is so huge, everything will be happening like a timetable. How it happens is because they are undergoing continuously pollination and self-pollination. Then what you understood by this, right? First thing is these self-pollinating flowers undergo pollination, always guaranteed pollination and guaranteed seed setting. There is no wastage of time. Continuously pollination is happening, fruits are formed. It is like timetable, everything happens, right? Therefore, here you can guess that this much yield I am going to get in 1 acre of land. So much of wheat I am going to get. That yield you can analyze. This is the yield I am going to get it. But in cross-pollinating flowers, it is not guaranteed. Why? Because imagine mango. Mango should undergo cross-pollination. Some seasons you will see huge number of mangoes, all cheap rated ones, all very good varieties. But in some seasons, 1 year, some years, it may be very few mango coming in the market, all are very costly. Why? Because cross-pollination might have failed. Right? There is a huge, beautiful relationship between the insects that are pollinating and the flowers. Right? If pollination won't happen, there is no fertilization, no fruit formation, no seed setting. Very simple it is. Simple logic. Therefore, suppose if at all you are cutting any plants or any trees and all, think so many insects and other things are related with that. They will have always coexistence. One plant is formed with, and it has to undergo pollination with particular insect only. Then the insect and the plant have evolved together. It's for the co-evolution. If that has not happened, then flowers wouldn't have got pollinated at all. Like you already know that in ficus, that's fig. Fig is your ficus. Fig, I hope you know. Anjura annu tiltare. Right? In this, some insects will pollinate it. They will enter into it. There will be a round inflorescence. They will enter into it. They lay the eggs, and young ones, when they hatch, they run around. They bring about pollination. Suppose there is no plant, all insects will die. If there are no insects, plant cannot undergo pollination. So this is a very fine relationship between the plants and the organisms, which we are not bothered at all. We don't even know what's happening in the nature. We are simply cutting the plants, simply using everything for our, thinking that human beings are the supreme things. But actually, that's not so. We are part of nature. Therefore, whenever you get a plant or a flower nearby your house, start watching how it's undergoing pollination. What are the insects pollinating? Most of the times, small insect will be moving here and there. Will be thinking, why these insects will come and bite me? Let me kill them. No, they will have some other work to do. If you come on the way, they may bite you. But that is not their prime work, to bite you only, right? So therefore, analyze the nature's delicate relationships, right? Therefore, self-pollinating plants are normally producing proper yield, good yield, no time wastage, 100% pollination, 100% seed setting. But what about cross-pollination? Cross-pollination is having some problem. What is that? If pollination, if it has to happen, either wind has to blow properly in wind pollinating flowers, or insect should visit at right time, or the bird should visit right time. If there is no visiting of these vectors, then pollination will not take place. So what is the disadvantage? There may not be guaranteed or surety in pollination. It may not happen at all. Pollination won't happen, no seed setting, right? No fruit formation. Second thing, the plant have to waste lot of energy. What for? To make the petals colorful, to make the fragrant glands, scent glands, and produce nectar. So much it has to produce, which is actually not necessary for the plant. It is producing for others. The visitors, it will produce all those things. So it has to waste a lot of energy for all these things. That's the reason why the plant will have to waste energy to do all these ornamentation, right? That time, what may happen? It may or may not undergo pollination. Again, that's a problem. And it has to produce large number of pollen grains, very attractive petals. See, everything is very, very costly for the plant. But still plant undergo cross-pollination. Try to undergo always cross-pollination. Why? Because cross-pollination can transfer the pollen grains from the non-related genus or species and transfer to this, so that there will be new genetic recombination. What is the use? There will be new character formed, there may be a mutation, there will be new species. It is must for evolution. Therefore, nature always wants to undergo cross-pollination don't want to undergo cell pollination, because cell pollination is like internal marriage, they call it internal marriage within the relationship getting married. But this is cross pollination is outside, marrying outside the relationship, outside the whatever we call religions, outside the continents. This produces the new varieties, we call that as the hybrid vigor. Hybrid vigor is otherwise called heterosis. What is heterosis or hybrid vigor? It is the superiority of the offsprings over their parents. If the two distant parents get fertilized or married, produce a child, child will be having from both of them the superior characters in it. Therefore, it is called as a hybrid vigor. Cross pollination always leads to the hybrid vigor. Cell pollination, actually slowly genes get weak and weak, and there will be slowly weakening of species, and sometimes fertility will be lost. It is called also as inbreeding depression, almost the same name it is. Therefore, understand both of them thoroughly and learn the story, because not much drawings are there, no drawings at all I am drawing. This is just to make you understand, but self and cross pollination you have to learn thoroughly. Okay, after this I am going to start with the various vectors involved in pollination. Okay, just go through, think about it.